Good day everyone. Today we will gonna solve this equation using integration by trigonometric substitution. First in solving this we need to look at first at the integrand, and our integrand here is the 4 minus x squared. In our integrand we have the a squared, in which it will be 4, and our b squared, in which it will be our x squared. Since our a squared is 4, then our a will be the square root of 4, in which it will be 2, and our u will be the square root of x squared, in which it will be x. Next, let us look at the different cases of the integrand. When the integrand contains a squared minus u, we will use the substitution u is equal to a sine theta. And in the second instance, when the integrand contains u squared plus a squared, we'll use the substitution u tangents theta. And in the last case, when the integrand contains u squared minus a squared, we'll use the substitution a secant theta. Here in our problem, since our integrand is 4 minus x squared, our integrand contains the first case, in which it is the a squared minus u squared. So now we will use the substitution u is equal to a sine squared. Our u is x is equal to a, and our a is 2, so a sine theta. And we will get its derivative. The derivative of 2 sine theta is 2 cosine theta d theta. Okay, next we will substitute our x and dx in our equation. Since our x is the 2 sine theta, then our x squared will be 2 sine theta squared times the dx, 2 cosine theta d theta, over the square root of 4 minus 2 sine theta squared. Now we will take the square root of 2 sine theta. 2 sine theta is 4 sine squared theta. Then we'll just copy the dx over 4 minus 4 sine squared theta square root. Our next step, we will extract 4 in this equation. We will just copy the numerator here. Then we will extract 4 in our denominator. Our term here will be 4. 4 1 minus sine squared theta. Then after this, we will use the Pythagorean identity in this equation. 1 minus sine squared theta here will become cosine squared theta. So our equation will be 4 sine squared theta 2 cosine theta d theta over the square root of 4 sine squared theta. So next we will take its square. So we just copy the numerator here. 4 sine squared theta 2 cos theta d theta over 2 sine theta. Next we also we got wrong here. This must be cosine squared theta. So our equation will be 2 cos theta. Then then say then then since we have a same term, we will just cancel 2 cos theta. So the remaining equation will be 4 sine squared theta d theta. Next, we will extract the we'll extract the 4 since it is a constant. So 4 times the integral of sine squared theta d theta. So here we can't just get its integral. So we will use the half angle identity. So sine squared theta will become 1 minus cosine 2 theta over 2 d theta. Then next we will extract the 1/2 here, the 1/2 of this equation. So it will become 4 times 1/2 times the integral of 1 minus cosine 2 theta d theta. Then we'll multiply these two, so it will become 2. Then we will get the and then we will integrate this term, and it will become the integral of 1 is theta, then the integral of cosine 2 theta is sine 2 theta over 2. Then next we will get the double angle identity of sine 2 theta. Then our equation will be 2 times the quantity of theta minus 2 sine theta cos theta over 2 plus c. Then we will eliminate the 2 since they are the same. Then we will distribute 2 in each term. So our equation will be 2 theta minus 2 sine theta cos theta plus c. So next, let's go back to our first equation. So first, let's determine our theta by substituting this equation into theta and sine theta. So x is equal to 2 sine theta. Then 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 first, let's determine our theta. So x, then we will divide both sides by 2 sine. So our theta will be x is equal to 2 sine. Then we will bring our sine to the numerator. So our theta will be sine arc sine times x over 2. Then we will find the sine theta by using again this equation. So x is equal to 2 sine theta. Let's just divide both sides by 2 to eliminate 2 here. So our sine theta will become x over 2. Lastly, we will solve cos theta, and in finding this, we need to use the Pythagorean theorem. So first, let's make a right triangle. So it is said that our sine theta is x over 2. And um and sine is as said in the Sukatawa, sine is equal to the opposite side over the hypotenuse. So that's why our sine theta is x over 2. So we just need to find the adjacent side of this equation, and in finding the adjacent side, we need to use the Pythagorean theorem, which is the a squared plus b squared is equal to c squared. So we all know that our c squared here is the hypotenuse, so we just substitute 2 squared in which it is equal to 4. Then we will substitute our a into x, so x squared. Then b squared will be the unknown. Then substituting this whole equation, b squared is equal to 4 minus x squared. Get the square root of b squared. Then we have an equation of b is equal to the square root of 4 minus x squared. Now since we have our b now, we just need to look for the cosine theta. So if our sine theta is equal to x over 2, our cos theta will become the square root of 4 minus x squared over 2. So now since we have all the equation we need to substitute our problem, so we will substitute it now. So our theta is the arc sine of x over 2. So 2 times arc sine x over 2 minus 2 sine theta, and our sine theta will be x over 2 times our cos theta, which is the square root of 4 minus x squared over 2. X squared over 2. So we just cancel the like terms. Then our final answer will be arc sine x over 2 minus x times 4 minus x squared over 2 plus c. So this will be our final answer, and thank you for your patience, and thank you for watching.